Hello, in this video I'm going to go through part J of question 1 on the 2012 math paper. So in this question, they've given us, this is a circle of radius 1, and we've got two chords, PQ and PR, and they meet at a point P at an angle of theta. And they want to know what is the largest possible area of this shaded region here. Okay, so when is the area of this shaded region going to be the largest? Well, if we imagine moving R and Q along this circle, say I moved R to here, well then I'd have to move Q along by the same amount in order for the angle theta to stay the same. So I'd have to move Q would come to about here. And so I'd be losing out on this red area here, but I'd be adding on the blue area. And we can see this blue area is a little bit larger than this red area. We can see that it's a bit longer. And so by moving R and Q in this direction, we've managed to increase the total area of the shaded region. So the new shaded region would be the old shaded region minus the red bits plus the blue bits over here. Okay, well, what if I kept moving R and Q in this direction? Say if I moved Q such that it was over here, and I moved, well, I have to move R by the same distance, so it'd be about here. So now we have that this PQ chord is now longer than the PR chord. Well, now we can see that the area that we're losing out on, which is this red bit, is bigger, it's longer than this blue bit. And so by doing this move, we've managed to decrease the total area of the shaded region, which is this, this now. So when PR was shorter than PQ, we were increasing area by moving R and Q along the circle, but then once PQ was shorter than PR, then we were decreasing the area again. So the maximum that the area of the shaded region can be is when PQ is equal to PR. So it'll be something like this, when these two lengths are, well, these two chords are of equal length. Well, okay, so now we just need to work out the area of this region. So the area of this green region here. And well, when looking at areas of regions of circles, I find it's generally useful to try and split this up into sectors and triangles. So if, let's see, so the center of the circle is about here. So I can use that, and I'll know that these two are radii of my circle, and this circle has radius 1, right? So these two lengths would just be 1. And, well, okay, so this angle is the angle subtended by this chord to the center. So this angle here is going to be twice the angle subtended at the circumference. And so because we know that this angle at the circumference is theta, then this angle subtended to the center is going to be 2 theta. So we can work out the area of this sector here. So the area of the sector is going to be the area of the circle times by the angle in the sector divided by 2 pi. The area of the circle is just pi r squared, and the angle is 2 theta. And also we know that r is just 1, so we know that this pi r squared is actually just pi. And then we see that we can cancel the pi with the pi on the bottom and the 2 with the 2. So we have that actually the area of this circle is just theta. Area of the sector, sorry. Okay, so now we've got to work out the area of this sort of arrowhead shape. So I'm going to split this up into 2 more triangles. So if I split this up into 2 triangles like this, then I know the side length of this is 1, and I also know that this is 1. And this angle here is just going to be theta over 2. And so if we use that the area of a triangle is equal to a half AB sine C, and we use that, well, we know the lengths of these two, so let's make these our A and B. So that means that this angle is going to be C. Well, we know that the angles in the triangle add up to pi, so we're going to have that pi is going to be equal to theta over 2 plus theta over 2 from these two angles, and then plus C. And so C is going to be pi minus 2 times theta over 2 is just theta, so it's pi theta. And so we have that our area of the triangle is going to be equal to a half times A and B are both 1, so 1 times sine of pi minus theta. And we see that this is a half times, and sine of pi minus theta is just the same as sine of theta, so sine theta. And well, we have that there are two of these triangles making up our shape, so we want 2 times the area of one of these triangles. So we have that the area of this whole sort of arrowheady shape bit is going to be just sine theta. And so we have that the area of this entire green shaded area is just going to be the area of the sector plus the area of this arrowhead bit. So we have sine theta as the area of the sector plus sine theta as the area of the other bit, and so we see that that is answer B.